Hello, my name is Phil Marriott. I'm a professor at the School of Chemistry at Monash University. Behind the camera is Mr. Habtewal Waktola. Habte is from Ethiopia. My laboratory does chemical analysis. The sort of chemical analysis we do is volatile compounds with mass spectrometry. The sorts of compounds of interest, therefore, are petroleums, drugs, beverages, and also food. And what we're going to talk to you about today is coffee aroma, and also some method in my laboratory, and also something on perfume analysis. We are part of the grouping called ACROSS, which is the Australian Centre for Research on Separation Science. So sit back and enjoy. I hope you enjoy this. The smell of freshly roasted coffee. Yes, that is freshly roasted coffee. We get our coffee, in this case, from Genovese. Genovese has sourced this coffee from Brazil, from Colombia, and from Honduras. But the most important thing is they blend the coffee to give the flavour that there are. Bennett's, where we got these green beans from, source the coffee from around the world, and then they sell it on to companies in Melbourne. So you can see here that these are raw coffee beans, green coffee beans, and they are very different to roast coffee. So if I try to smell the raw coffee bean, it smells vegetal. It certainly doesn't smell like coffee. So something happens to produce roasted coffee from raw coffee bean. First of all, commences with a preheated, normally gas-fired oven, a rotating drum. During this process, we go from raw bean to a roasted bean. Here we can see the difference between the roasted bean and the green bean. So what happens here is that the heat of the oven causes an expansion of the vapor and the moisture inside of the bean, plus the triglycerides and other compounds, to crack the bean. And the cracked bean, the first crack of the bean, occurs as the temperature is increasing. At the same time, various reactions occur that go from a green bean into the magic that is the roasted bean. We can also go through a second roasting process, or second crack process, which means that the coffee is then further heated, but sometimes this produces an extra bitter coffee. So sometimes a coffee company might choose to roast between the first crack and the second crack. Okay, those of you who are in Year 12 chemistry have probably already finished your units on chromatography and mass spectrometry. I think sometimes that's in the first semester. But this is the way we do our chromatography work. First of all, we have a first column, but we also have a second column. We call this multi-dimensional chromatography. But what's special is a modulator system, which is a cryogenic system, which I developed some years ago, and it's been patented. Now what happens here is that the compounds that are inserted into the first column pass through the second column, but the modulator causes them to periodically stop movement and then pulses into the second column. The net effect is what we can see down here. So we see in this process all of these compounds, which are separated, shown here as separate dots on the two-dimensional space, are all completely resolved compounds. Even the tiny compounds here, and these might be very important for something like the flavor of coffee. Without doing this process, what we see is what we call a single column analysis, but there's no separation in the second dimension. And so under this peak, we don't know that there are all of these other components. And this is where this technique has a particular advantage by showing everything which is in the sample. We work with a perfume company called Firmenich. Firmenich is from Geneva in Switzerland. They're one of the biggest wholly owned private companies in perfume analysis or in perfume creation in the world. Firmenich use gas chromatography extensively in their operation. And the way they use gas chromatography is to confirm the quality of the products that they make. Well, Firmenich employ perfumers. Perfumers sit in a room with maybe 2,000 fragrances around them. There'll be natural fragrances and some of them will be synthetic fragrances. The client will come to Firmenich and they will come with a concept. The perfumer sits down with the client and they'll come up with a concept. And they create these very small vials with testing different fragrance combinations. When they come up with a preferred fragrance, the client might say, that's exactly what I want. The perfumer then has to pass this on to the factory, and the factory instruction might be, can you please create 1 ton of the perfume that the client wants? Now, this has to be done very carefully, because if the perfumer has created the perfume using in a very small vial, the client agrees on that perfume, they have to make sure that when it goes to the factory, it's exactly the same perfume, this is exactly the same aroma. Otherwise, the client might say, sorry, it's different. I don't want that because that's not what I requested you to make. So let's see who some of the clients are that Firmenich have worked with. Well, here's one that everyone will know. This one is Chanel No. 5. This was created by Firmenich in 1921. The company's been around for over 100 years. Chanel No. 5 is classified as a floral perfume, but also aldehydic. So that's a sort of fragrance nuance that Chanel No. 5 has. Another product of Firmenich is Ralph, which is from Ralph Lauren. Ralph Lauren, this was created in 2000, but of course it was created by Firmenich. This is classified as a fruity flavour, a fruity type perfume. Now, what the perfume company does is take the product from Firmenich, maybe 1 ton or 2 ton, and they put it into bottles and they sell it at airports and in chemists all around the world. So really, a perfume company is no more than a bottling company. The creator of the perfume is Firmenich with the client. Now, how do they use gas chromatography? Well, one of the things they do is when they produce the final product, they do a gas chromatogram of it, which means to say they separate all of the flavour and perfume components. And using that, they then have got a fingerprint of the composition of that perfume. And you can imagine what would happen if Chanel No. 5 says the next year, we had a wonderful sale on this perfume, can we please have some more? Well, Firmenich have to make sure that the perfume is exactly the same year to year. And you can see here from 1921, they've been in business for almost 100 years selling Chanel No. 5. And you would hope that Chanel No. 5 smells the same now as what it did 100 years ago. And you could imagine that if there was a change in perfume aroma, if you bought Chanel No. 5 from an airport somewhere and you smell it, you might think, this is not the same as what I bought in Paris. You might think that the airport is selling a fake Chanel No. 5. So you want to make sure that the perfume is exactly the same year to year. For all of these products, gas chromatography measures these compounds, ensuring the quality of what they produce.